Hello, good morning. Today we will continue with the response of LTI systems. Under this, we will cover discrete time systems. We have seen how the differential equation that is written down for the continuous time system. Now we are considering a discrete time system. So in this case, instead of having a differential equation, we will have a difference equation. Difference equation means it will have the kth sample, k minus 1 sample, k minus nth sample and so on. So this is introducing a delay of one sample. So that is called as the difference equation. Now in this case we are assuming that the initial conditions are 0 and we are writing the equation as yk plus an minus 1 yk minus 1 plus etc. up to a0 yk minus n is equal to bm fk plus bm minus 1 f of k minus 1 etc. up to b0 f of k minus n, where f is the input to the system and y is the output of the system. Now in this case, how we solve this difference equation? What we'll do is we'll first solve y0 and then we go on evaluating y1, y2, y3 etc. That is called as the recursive solution. So we'll go on recursively finding out the values of y. Consider for example the equation given by yk minus 0.5 yk minus 1 is equal to f of k with initial conditions given as y minus 1 is equal to 8 and f of k is equal to k square. So whatever is the value of k, you can find out what will be f of k. Now what I will do is I will put k equal to 0 in this equation because I want to calculate y0 first. So what will be y0? Y0 is minus y0 minus 0.5 y of, when I put k equal to 0, I will get y minus 1 equal to 0. And in this case, we can write down the value of y of minus 1 as 8. So it will be y0 minus 4 is equal to 0. So y0 is equal to 4. Now put k equal to 1 in the equation. So I will have y1 minus 0.5 of y0 is equal to f1. Now y0 we have already calculated, that is equal to 4. So I put the value of y0 in this case. So I will get y of 1 is equal to 2, 0.5 into y0 is 2 plus fk is k square, k is equal to 1. So in this case fk will be equal to 1. So I will get y1 is equal to 3. Similarly, I can go on calculating y2, y3, y4 etc. This is called as recursive method. Now let us see how we can write down the generalized difference equation. As I told you, in this case it will not be a differential equation, it will be called as the difference equation. Now in this case, a delay of one sample, we will represent it by capital D. So f of k delayed by one sample will be f of k plus 1 and so on. So we can write down the generalized equation as d raised to n plus a, n minus 1, d raised to n minus 1 etc. into y of k is equal to some constant bm into d raised to m plus bm minus 1 d raised to m minus 1 etc. into f of k. F of k is the input. So if I write down yk divided by fk, this will be the numerator polynomial and this will be then the denominator polynomial. So this denominator polynomial we can analyze and then we can find out what are the roots of this particular polynomial. These roots are nothing but the eigenfunctions. Now in this case, if the degree of numerator is greater than that of denominator, the noise will be amplified and the system will become unstable. This discussion is same as that we have done for continuous time systems. And if m is less than n, then the system will be stable. So we either assume m is less than n or m is equal to n of, at the most. wherein there will be only the unit impulse response. And when m is greater than n, we avoid this case because in that case the system will become unstable. Now let us see how to calculate the zero input response. Now in this case we consider an example to show you how the response can be calculated. We are considering the equation y of k plus 2 minus 0.4 into y of k plus 1 minus 0.12 into yk is equal to 5 times f of k plus 2. Suppose this is the equation, difference equation given to you. With y of minus 1 equal to 0 and y of minus 2 equal to 25, these are the initial conditions. Now what is fk? Fk is given as 4 raised to minus k uk, but when I am considering zero input response, the input will be considered as 0. Now this difference equation I can write it as d square y of k plus 2. In this case there is a delay of 2 samples, so I write it at d square minus 0.4, here there is a delay of 1 sample, so d minus 0.12 is equal to 0. This becomes the characteristic equation. We first find out the roots of this characteristic equation. The roots of this characteristic equation will be 0.6 and minus 0.2. As you can solve this and see. So I can write yk, that is the generalized equation, as some constant c1 into 0.6 raised to k plus c2 into minus 0.2 raised to k. This is the generalized equation, generalized solution. Now I'll have to put the initial conditions, y1 minus 1 equal to 0, y of minus 2 equal to 25. So put k is equal to minus 1. So I'll get y of minus 1 is equal to c1 0.6 raised to minus 1 plus c2 minus 0.2 raised to minus 1. So I get this is 0.6, so it is 3 by 5 raised to minus 1, it becomes 5 by 3. So 5 by 3 c1 minus 5 times c2 on similar lines. So I get this equation 5 by 3 c1 minus 5 c2 equal to 0, or I can write 1 by 3 c1 minus c2 equal to 0. Then I put k equal to minus 2, so y of minus 2 will be equal to c1 0.6 raised to minus 2 plus c2 minus 0.2 raised to minus 2 is equal to, I solve this will be square of 5 by 3, so it will be 25 by 9 c1 plus square of this 5, so 25 c2 is equal to 25. Now I solve these two equations. Solving, I will get the value of c1 as 9 by 4 and c2 as 3 by 4. So I get final solution as yk is equal to 9 by 4 0.6 raised to k plus 3 by 2 minus 0.2 raised to k. Now in case of continuous time differential equation, we used to write the solution as e raised to something, that is exponential terms. Now in this case we write it as r raised to k, right? That is the only difference. Now let us see how the discrete time systems can be represented. So this is some linear time invariant system, and input to the system is given by k1 x1n plus k2 x2n. That is a linear combination of two inputs. So what will be the output? Output will also be the linear combination of the corresponding outputs, that is k1 y1n plus k2 y2n. This is what I mean by the linear system. Now consider the sequence given by xn is equal to 1, 2, minus 1, 2 and 3. When I put the arrow over here, it indicates that this is the value of 0, x0. So this is x0, x1, x2, x3 and x4. So how I write xn? Xn is equal to delta n, that is the value at n equal to 0, then n equal to 1 twice delta n minus 1. Why twice? Because here the value is 2 minus delta n minus 2 plus 2 delta n minus 3 plus 3 delta n minus 4. Right. So this is how I decompose the input xn in terms of scaled and translated delta functions. So if I know the response to the delta function, that is impulse response, I can calculate the response to any input xn. by decomposing it into a scaled and translated delta function. Now, when I say it is LTI system, that is time invariant system, the response to delta n is Hn, that is the impulse response. What will be the response to delta n minus 1? It will be h of n minus 1. Response to delta n minus 2 will be h of n minus 2. Response to delta n minus 3 will be h of n minus 3. It will be just the shifted response, because in this case we have used the shift invariance property. Now consider the input side algorithm for convolution. I have this input sequence xn given as 1, 2, 2 and 1, and the impulse response is given by 1, 2, 1. Now what is the meaning of input side algorithm? Input side algorithm means from input side we see corresponding first value of the input sequence, that is delta n. This delta n contributes to how many outputs? It contributes to the output at 0, it contributes to the output at 1, it also contributes to the output at 2. Now if I consider the shifted response, that is the response to this twice delta n minus 1, what will be the response? It will be a shifted response. So it will be equal to twice the corresponding response value for this n minus 1, n minus 2 and n minus 3. Similarly, this is delta n minus 2. Now again it will be a shifted response like this. For this, that is delta n minus 3, the response will be like this. Now what I am supposed to do at the output? At the output, add up all the contributions from the different inputs. At n equal to 0, the output will be contributed only from this delta n. So it is equal to 1. At n equal to 1, this will contribute, that is the delta n will contribute and delta n minus 1 will also contribute. So this is 2 plus 2, it will be equal to 4. In this case, this delta n will contribute, delta n minus 1 will contribute, delta n will contribute, delta n minus 1 will contribute, and delta n minus 2 will also be contributing. So 1 plus 4 plus 2, that is 7. In this case, it is again 2, 2 plus 4 plus 1, so it will be 7. Now in this case, it is just 2 plus 2, it will be 4, and in this case this will be 1 alone. So I am looking from the input side. What will be the response to delta n? What will be the response to twice delta n minus 1, twice delta n minus 2 and delta n minus 3? And at the output n, I just find out the corresponding contribution from different inputs and add it up. This is what is called as input side algorithm. Now consider output side algorithm. For the output side algorithm, I see from the output angle. So at this at n equal to 0, which one will contribute? Only this delta n will contribute. That is the first sample. At this second sample, this will contribute and this will also contribute. At this particular n equal to 2, this will contribute and also this will contribute. At this particular instance, this will contribute, and this will also contribute. At this particular point, this and this will contribute. At this particular point, only the last one will contribute. So I just try to find out which contributions are coming from which particular input sample and then consider the addition. This is output side algorithm. So it is the same thing, we are getting the output same, but you have to see there are different methods. This is the conventional method. So I write xm 1, 2, 2, 1. Then h of m, I just invert. I write h of minus m 1, 2, 1. Now what I do? Firstly, I just find out 1 into 1. How much is that? 1 into 1 is equal to 1. So at n equal to 0, it is 1. At n equal to 2, what I am doing? I am just shifting this h of minus m. So I am making it h of 1 minus m. So it becomes 1 here, 2 here and 1 here. So 2 into 1. Now I do sample by sample multiplication. 2 into 1 plus 2 into 1, so 2 plus 2, 4, it comes here. Now when I shift it ahead, this 1, 2 and 1, all these three samples will overlap. So 1 into 1 plus 2 into 2, that is 4. This is 2 into 1, that is 2. So 4 plus 2 plus 1, that is 7. Now at this particular case again, I am going to shift it. So 1, 2 and 1 will overlap. So 2 plus 4, 6 plus 1, again I get 7. At this particular instance, I again shift it towards right. So only 1 and 2 will overlap. 2 into 1 plus 1 into 2, it becomes 4. And when I shift it further 1 to 1, only one sample overlaps and I get the output as 1. This is what is our conventional method of doing the convolution. Now this is, I have written one simple program using MATLAB for calculation of convolution. What you are supposed to do is you are supposed to write down the corresponding x and corresponding h and then write a convol conv command x comma h. Then it will convolve and it will directly give you the output. So here this is 0.3 raised to 2, 0.3 raised to 3 and so on. So this is the corresponding output that has resulted. So you can directly find out the convolution output. Now consider how we can find out the unit step response. Unit step response means the input will be unit step. And then we have to convolve the impulse response of the system with the unit step which is applied as input. Now let us see. So consider for continuous time systems first. So let us try to convolve the corresponding impulse response ht given by ut minus ut minus 2 and we have to convolve it with ut, right. What is ht? Ht is ut minus 2. So it is existing only between 0 to 2, that's right. Now convolve it with un. So what I'll have to do? I'll have to take the mirror image of this un and I start with the maximum negative value, go on shifting. So when I shift this right and edge, until I take it up to 0, there is no overlap. So the output will be 0. So below 0, the output is 0. Now when I shift it further, what will happen? There will be the overlapping interval between 0 to t. So for 0 to 2, the corresponding interval of overlap will be between 0 to t and I will have to integrate between 0 to t, 0 to t. The corresponding value is 1 here, value is 1 here, so just d tau. So if I consider tau between 0 to t, I will integrate and I will get the value as t. So at every value of t, it will go on increasing up to 2. Now what will happen after 2? When I shift it further, the corresponding overlap will be between 0 to 2 and this will be fixed. So when I integrate, the integration will be carried out between 0 to 2 and the answer is 2. So the output will remain constant at 2. Consider one more example. Now in this case I am having ht written as delta t minus 2. That means the samples exist at t equal to 0 and t equal to 2. The t equal to 2, the sample value is negative. And I have to convolve it with ut. On similar lines, what I will do? I will go on shifting this ut, that is this right edge, I will go on shifting until I shift it towards t equal to 0. Till t equal to 0, there is no overlap. At t equal to 0, what will happen? This value is 1, this value is also 1. So the output will be equal to 1. And I go on shifting it just before 2, still the value will remain 1 because the sample corresponding sample at this particular point will overlap. If I shift it further and take it away from 2, take it ahead of 2, then one sample here overlaps and one sample here overlaps. This is 1 and this is minus 1. At 2, it is minus 1. So 1 plus minus 1, it will give you 0. So above 2, it will be 0, and just less than 2, it will remain 1. Now consider a DT system. So I have the corresponding impulse response given by delta n minus delta n minus 1. So similarly, I have a sample at 0, I have a sample at 1. Now I have to convolve it with un. So what is un? Un is existing, it will be equal to 1, and it is existing for all n greater than or equal to 0. Now what I do, I just go on calculating the output. I go on shift, take this mirror image of x of n, so I get x of minus n, and I just take the sample by sample product. So this is 1 here, this is 1 here, the output will be equal to 1. When I shift it further by one sample, this is 1 and this is minus 1, so output will be 0. At 2 again, only 2 samples with overlap, one will be 1, one will be minus 1, so it will be 0. So for all further values, it will be 0, and what will be yn? Yn will be only one sample at n equal to 0, so I write it as delta n. Now this is one more example for DT systems. I have impulse response given as equal to 1 between 0, 1, 2 and 3, and it is equal to 0 otherwise. And this xn is the unit impulse, that is un. So xn I just invert and just go on shifting. For the first sample overlaps at n equal to 0, I get y0 equal to 1. At 1, 2 samples overlap, so I get 2. At 3, 3 samples overlap. At 4, 4 samples overlap, and so on. So what will be yn? Y will be equal to n. Sorry, I think I said for hn it is existing only up to 3. No, it is dotted line here. So it is existing for all n greater than 0 because hn is equal to un. Okay, so it will be increasing. At every sample, the corresponding output will increase by 1. So it will be 1, 2, 3, 4, etc. up to n. So it will go on increasing. Right. So at infinity, it will go to infinity. It is not a stable system. Now consider the unit step response of DT system. This is one more example that I am considering. Hn is given as half raised to n un. Okay, half raised to n un. So how it will be? It will be at 0 it will be 1. At 1 it will be equal to half. At 2 it will be equal to 1 by 4. 3 it will be equal to 1 by 8. At 4 it will be 1 by 16, and so on. Now I take un, I just invert it, and I go on shifting. So at n equal to 0, only one sample overlaps. The value is equal to 1. Y0 is equal to 1. At y1, 1 plus 1 by 2, then 1 plus 1 by 2 plus 1 by 4, then 1 plus 1 by 2 plus 1 by 4 plus 1 by 8, and so on. Right. So I can write yn in general as 1 plus half plus 1 by 4 plus etc. up to half raised to n. Right. All these will be added up. So output will be 1 minus half. So this will be equal to half. So I take it as 2 in the numerator, and then 1 minus half raised to n plus 1. So in general format, I can write yn as 2 into 1 minus half raised to n plus 1. I hope you have understood how the convolution will be carried out. Thank you so much.